Good morning. This is again Professor Shah signing on. We are going to the third stage of Unit 2, the last stage of Unit 2. I think it's a very fascinating concept to study about it. That is called, the topic is iteration and recursion. So, shall we ready to go for it? Iteration. Iteration means what? Repeatedly a body executing is called iteration. அது தமிழில் சொல்லுவாங்க திரும்ப திரும்ப எக்ஸிக்யூட் பண்ணுவாங்க இல்லையா அதை தான் ஐட்ரேஷன் சொல்கிறது iteration. அப்போ ரிகர்ஷன் என்னது? வாட் இஸ் ரிகர்ஷன் சார்? எ ஃபங்க்ஷன் காலிங் இட் செல்ஃப். எ ஃபங்க்ஷன் அதே கால் பண்ணுனா ரிகர்ஷன். ஓகே, நவ் எக்ஸாம்பிள் வி வில் ஸ்டார்ட். Iteration, so invariant. See the fun, how the mechanism is. I got a dash dash in input. Before the starting, u value the 10, v value on the 15. Then what you are doing? U plus 5, v minus 5. 20 plus 5, 25. V minus 5, 15 minus 5, 10. 25 and 10. So u was 20 initially, 15, 25 and 10. The next step, what is u plus v? The 25 plus 10, 35. This is the mechanism. Understood or not? Why you are talking about this, sir? Because we are talking about invariant. Sir, invariant means what, sir? Actually, the value never varies. We are not understanding, sir. You got a for loop, for example. For I is equal to this, I is less than 10, I plus plus. You're doing a loop. Inside, you are using j is equal to 1. But the j has got no business there. So this is invariant. J is always you're assigning 1, 1, 1. What is the use? That's called invariant. Understood or not? Before p value is 10, c value is 9. Increment means 10 plus 1, 11. 9 plus 1, 10. That's what. So loop invariant. Shall we start the class? Okay. Start of loop. While the condition is executed, do this. No, do this. Sir, we study little bit. Could you give some more example? Invariants. Sir, when you're doing a function, some constants will be always common. So keep that as a global declaration. That is also invariance. Okay. So the value never changes. That's what you want to say, yes. Okay. So now iteration we said repeatedly you are calling. Understood, sir. What is recursion is a function calling itself. I'll go example. You tell me the one example for it. Closely related to induction. Induction means what? Self-improvement. Function calling function. For example, queuing function. This is the queue. A counter is here. A is in the first man, B is the second man, C is the third man, fourth man, fifth man. Once A job is over, he will be driven out. So Q will be decremented by 1. Q has got two characteristics. One is entering the queue. Once the job is over, leaving out the queue. Entering the queue in the tail, operation happening is in the head of the queue. So A would a queue length how much? Only 1. B would a queue length 2. C would a queue length 3. D would a queue length 4. E would a queue length 5. This is called queue length. Have you studied? A's queue length is what? That is the first man to be getting counter. So 1. B, let the A will be over, B will come. So 2, 3, 4, 5. This is called queue length. Example, length of the queue. How to find the length of the queue? 5 men are there. 1, 2, 3, 4, 5. So I will say length of the queue is 5. Who is first in the queue? I told you already. A queue is like this. First is A, B, C, D, E. Here is the count. Who is the first man came inside? A. Who is the, once A is over, what will the remaining B, even A is over, B, C, D. Who is here? B, C, D. A is over, sir. So B, C, D. That is called rest. First rest. So in the rest, once B job is over, who is the rester? C, D. Once the C is over, who is the rester? D. Once D is over, who is the rester? F. So length is 1 plus 1, 1 plus 4. Understood or not? This is called Q length. Quite fascinating, no? So, for example, initially I got 1. Next, our length was length 1. Example, I'll teach you. Don't confuse. I'll teach you. Number first is the length is nobody was there executed. Only all members were there. Y, A, B, C, D. All members will be there. A. Once A is over, what is the happening? Length 1 is over. Remaining resting are B, C, D. A job is over. Rest. Then B is over, length rest is CD. Then length DE. Then length E. So totally 5. Q length is 5. So similarly, shall we compute the power? Obviously. How, sir? A into A raised to n minus 1. Suppose you want to compute the A power n, I will compute like A into A power n minus 1. Am I right or not? Or I can say A star A into n minus 2. Studied or not? So what? First A power n you are going to compute. This will be computed. First I will take A. Remaining is what? A power n minus 1. This is the rest. Second has come. So A has come, B has come. So remaining is A power n minus 2. Rest has come. The third one is A star A power n minus 3. This is called AQ. Understood or not? Understood or not? That's what? A into power of A minus 1. This is a generalized concept. So we are not understanding generalized concept means what? If n is equal to 5 you take. What is A power 5? So A into power of A comma n minus 1. 4. That is A into A power n minus 4. Sardana? N if n is 4. That is 4. A power 4. Otherwise I can write A into A power 3. What happens? I got a A and initially it was 5. It has become n minus 1, n minus 2, n minus 3. But here A gets increment. I'll teach you, don't worry. Power 2 comma 5 for example. 2 is the base, power is 5. I can say 2 into power, see the function, A is 2, power of 2 comma 5 minus 1 is what? 4. So 2 into 2 power 4. What is the value? 32. So already it is there. So why? We are decomposing. 2 power 4 I can write. A is over. Rest is 2 power 4. So I will write 2 power 4 as a 2 into 2 power 3. 2 power n minus 1. Rest. Then 2 into 2 into 2. 2 power 3 will become 2. Why? N minus 1. Rest. Next rest is 1. First A value is 2. Second A value is 2 into 2. Third A value is 2 into 2 into 2. Fourth A value is 2 into 2 into 2. Fifth A value is 32. How? First A is 1, 2. Rest is 4. Here A will become 4. Rest is 3. Then A will become 3. Rest is 2. A will become 4. Rest is 1. So 32, 4, 8 is 32 is the answer. Understood or not? So you are going to compute 2 to the power 4. How to compute it? Tell me. 2 to the power 4. So first I will do power a into power of a value is 2. 2 to the power of 4 minus 1. What happens? A into function name 2 power 4 minus 1. 2 power 3. Both are same, no? A into 2 power a to the a is 2 means so 2 into 2 power 3. So A business is over. Who are all remaining? B, C, D. Second stage B business is over. So 2 power 2. Again if you improve 2 into 2 into 2 into 2 power 1. Similar. Understood or not? So what is a function calling itself? That is, you are reducing the power. Initially it was 4, 3, 2, 1. That's what we are doing. Understood or not? Is it easy for you to study now? So this is called recursion. If anybody has a question, so what does recursion say? This is the answer for recursion. So do you have any other problem? Yes, towers of Hanoi problem is there. So what is towers of Hanoi problem? For example, you take 3 poles are there. You have got 3 discs. One is A, B, C. I want to transfer completely from 1 to 3rd pole, but should not 1 to 3rd pole. We have to reach A, B, C. So CBA, no. Only highest power, bigger size will be bottom, smaller size will be top, still smaller is top. So I have to transfer. How to do it? Do it. That is called recursion. What I'll do, I'll take the first C. I'll bring the B. B again C will come here. A will come here. This is called actually n numbers are 3 numbers are there. I'll take 2 elements here. There is n minus 1. Understood or not? So function calling, so don't confuse anything. In the examination point of view, I am telling a function calling itself is called recursion. For example, here 2 to the power 5 means how to compute. For example, towers of Hanoi means how to compute. How to compute the factorial. Factorial means what? 5 factorial. 5 into 4 factorial. Am I right or not? I am decrementing. See, n minus 1. N is usually 5. So n minus 1 means 5 into 4 factorial. Again you are calling a function 4 into 3 factorial. 5 into 4 into 3 into 2 factorial. This is called actually a recursion. So now we are closing the topic of unit 2 with chapter 3, stage 3. So again now we are slowly migrating towards the topic of unit 3 with still more information with fascinating concept. So this is again I'm requesting you subscribe the button. Then okay, that's quite common. Then okay, so this is Professor Shah again signing off. Thank you.